So my name is Ryan Davis. I'm with the Seattle Ruby Brigade. I'm one of the co-founders. I'm also, as you've heard, with Engineered now, working on Rubinius. So a couple notes. I'm getting over a cold, so and I'm on the East Coast, which is 3 time zones wrong. This is about the time I wake up, so I'm a little out of it right now. So apologies if I fumble. I gave a version of this talk at RubyConf 2007, and I received a lot of really good reviews from that. And I was really proud of that talk because it encompassed my message and my mission about as lucidly as I was able to ever state it. Unfortunately, the recording of it was munged, so I'm really grateful to be able to be here today and give this talk to you. I'm going to be talking about hurting code. I need to make sure that I can use my remote. Describing what I call Ruby asceticism, Ruby asceticism, and introspection-driven development. Oh, you're right. Sorry about that. I blanked it out. So I'm going to be talking about Ruby asceticism, Ruby asceticism, and introspection-driven development. So to set some expectations, I have 142 slides in 45 minutes. This is going to be fast. I'm very much oriented on signal versus noise. So hopefully I'm fast enough to have some time at the end. And last time I gave this talk, I still went way too fast. So there was a lot of time for QA, and that's good because it seems that this is a new topic for some people. And this is a departure from my usual type of talk. It's more about improving yourself than it is about code. A lot of my talks have a lot of code and a lot of runtime and demos and stuff like that. This isn't one of them. I don't think I have any code in here, actually. So let's start off with the story. So once upon a time, there was a developer. And the developer goes to a new place. And whether the new place is a new job or a different department or just a different or new project, it really doesn't matter. The point is that the developer comes across legacy code. And as we all know, legacy code is any code you haven't written yourself. And every company already has tons of legacy code, even startups. And I should amend that. Legacy code is any code you haven't written in the last 2 weeks. So the developer sits down at his shiny new workstation and pulls up the editor and starts going through the code. And in order to learn one piece that he needs to work on, he needs to learn another. And in order to know that, he needs to learn another, and so on and so forth. And he uncovers a rat's nest. This makes the developer angry. So he does the only thing that's right. And he kills and maims all the people that are guilty for that code. And promptly goes to jail. The alternative is, the developer goes to a new place, sits down at his workstation, starts opening up the code and looking at it, studying it, discovers a rat's nest, gets angry, but then pulls out his toolbox and starts going through, one by one, dealing with the problems, until that developer is shown the code who's boss. And the developer's happy. The end. So what's the moral of the story? The moral of the story is actually quite simple. People will press charges if you hurt them. Code won't. So hurt the code and stay out of jail. So this talk is a coming out event for me. My name is Ryan, and I like to hurt code. And I'm okay.
Hi, Ryan.
Thank you. So why hurt code? Well, hurting code for me is a lot of fun. It can make you a better tester and a better developer. And I think we should all be both. It can make your code cleaner, clearer, and easier to test, to write, to maintain, and it can even make it faster. So Ruby sadism is the tendency to derive pleasure from inflicting pain on software, especially bad software. And it's really just a perspective. It's another way of looking at software development. And any of you paired with me knows that I cackle every time I find code that I can punish. And some of you are in this room right now. I'm pointing at you. Code that has complexity, I know that I can strip out, that I can hurt. And it's about changing your perspective on bad code. If you make it fun to hunt it down and fix it, you're going to do it more often, and you'll wind up with better code over time. And Ruby sadism comes in many, many forms. Killing a bug by writing a new test. Reading overly clever code and itching to rip it to shreds. Nuking bad design, making it faster with less code, and many, many more. Can anyone come up with any other examples? Anyone else hurt code? Everyone have turkey for lunch? Okay, we'll move on. So as an example, I was working on what should have been a 2-month social media Rails project that was dragging on for 12-ish months. And one of the problems and I think it was the main problem that was going on, was that they were trying to tie active record to WebDAV for scaling. And the thing is that WebDAV is a transport serialized over HTTP via XML. So every time a web browser was making a request to a Rails app, that Rails app was wanting to make a DB request, but instead it was going through WebDAV, hitting another server with an XML serialized request that would go to the WebDAV server, which would deserialize the XML, process the request, figure out the result, serialize that in XML, respond back with the XML, which would then have to be deserialized again, and then it could finally do something Railsy with it. That's needlessly complex and slow. The whole thing, every row and column was supposed to be a WebDAV property. And that's just insane. So I ripped out WebDAV over the weekend, and the results were really dramatic. Whereas we started with average runtime, and these are not scientific numbers, but an average runtime of 75 seconds for 622 tests, which really is not that many. Afterwards, we were doing roughly half the tests, because I ripped out a lot of the tests for the WebDAV side of things, but we were doing it 15 to 20 times faster. And you can see this over time. I'll try to cursor this. Mousey. Where's the mouse? The mouse is not working. Anyways, you can see on the left half that as time was going on, and really when I started, the tests wouldn't even consistently run, and we had to work on that. And so once those got fixed up and consistent, the test times were consistently going up. And you can see that over time in the first 6 months, or first 3 of the 6 months. And some of the spikes are dramatic, some are not so much, and we'd spend some time fixing the runtime. And then we'd spent a concerted amount of effort doing profiling and optimization, and it helped a lot. You can see us go back down to some of the original times, but it plateaus. It only helps so much. It helps to a point. So I fixed the design by ripping DAV out, and you can see that dramatic drop down to the 5-second range, and we plateaued for a while, and then you see a little spike as we were able to, because the code's more usable, we were able to add a lot more tests. And that's why the time's starting to go back up again. Those are good peaks, whereas the other ones are bad. So for some reason, people love complexity. They revel in it. And the Ruby community is not unique in this regard. I think it's just a human trait. I'm not one of those people, but I used to be. I got better, and you can too. And you can see here, and I don't know how well you can read this, I've got a graph here of my programming history with the years on the x-axis and my foo units on the y-axis. And yeah, I've had my ups and downs. I've done BASIC, I've done C and C++. I even got really good at those for what it's worth. It wasn't until I really embraced OO and had my epiphany in 91, and then started embracing smaller, lighter languages, scripting languages, that it really helped me grow. And you can see that with Perl and Python and Ruby. But it was the sadism and asceticism that helped me improve non-linearly. I can do a lot more now with a lot less. It's a multiplier. So Ruby asceticism is the next component, and that's characterized by, or suggesting the practice of severe self-discipline and abstention from all forms of indulgence. So we got self-discipline and abstention, and we got this thing called indulgence. We'll go into those in a second. And virtually all major religions do have or have had ascetic subgroups. And probably the best well-known one is the flagellants. I wish I was brighter. So many of you are already practicing various pieces of asceticism, and you might not know it. Test first is a form of self-discipline. When you stick to that practice, and you write your test first, and then you do your implementation, that self-discipline is helping you be ascetic about your code. Yagni, where you're not going to need it, is a form of abstention. So ascetics, let's compare and contrast between real life and Ruby. In real life, they eschew material possessions, and we eschew extra complexity. And in real life, they're self-disciplined to achieve higher spirituality, and we're self-disciplined to achieve better understanding of self, the coding mind, and the code itself. So what's this indulgence part? That's the complex part. Now, it's needless complexity and over clever code. It's coder design that you don't immediately need. It's what I call the whatabouts. Now, who here knows what the whatabouts are? Have you ever experienced whatabouts? Can anyone give me an example of whatabout?
What if we need this down 6 months in the road, maybe?
What if we need this down 6 months in the road? Maybe, exactly. It's all the stuff you don't need right now to solve the task at hand. It's the tangents, it's the crap. It's the code creep, and it absolutely sucks. And I don't know how many times that I've paired with someone, and every 10 to 20 seconds, you hear, well, what about this? Or what about caching, or the speed? And I hate speed. If anyone says speed, I'll beat you down. Because speed's not a problem until you actually run it and measure it. Once you have objective data, I mean, it's important, but until then, it's mentor baiting. And then there's this idea of technical debt, which comes from Ward Cunningham. But I learned initially taking a workshop from Dave Thomas and Andy Hunt at Oopsla 2000, which was also the reason why I was doomed to learn Ruby. And the concept's really interesting when you change the way you think about this stuff. So skipping or deferring design is like borrowing. It's taking a debt. And refactoring is repaying the principal. But the interest that you pay is done as time dealing with that complexity that you already have. And if you start thinking about this as every time you defer, it's an investment, you change your perspective on the way you write code. 80-20, also known as the Pareto principle if you want to sound educated. In most systems, there's a severe imbalance between producers, consumers, money, people, et cetera. What Pareto found was that 85% of the land was owned by 5% of the people in Italy in like the 16th or 17th century. What we often see is that 80 or some high percentage of the time spent is only in 20 or some low percentage of the code. And we can use this tendency to focus our efforts efficiently and objectively by measuring the code and dealing with the problems at hand. Often related is signal and noise. It's about focusing on what's important. It's not so much about the code itself, it's about your process and how you work. So unclutter and minimize interruptions and extraneous tasks to get the real work done. And one of my best managers, and I don't say that often, loved to say big alligators, little alligators, swamp, which befuddled me as well. But what it means is before you can build a castle in a swamp, there are certain things you need to deal with in a proper order. Because if you drain the swamp too soon, you're going to get bit. And Ward Cunningham beautifully said this. A developer's obligation is to make sure that the code as written makes the clearest possible statement as to how the solution was understood at the time of writing. And I think that's beautiful. I like it for two reasons. One, he's obviously giving the point that you need to be as clear as you can. But he's also taking into consideration that has to do with your perspective on the problem at the time at hand. Those things go hand in hand, and they evolve over time. So as an example of asceticism, test unit and RSpec are the kings of testing and specking, but they're really, really big. I am supposedly the maintainer of test unit, and I'm terrified of working on it whenever bugs are filed against it, because I don't understand the code, and it's really hard to get into. Brian Ford of Rubinius, he wrote mspec, which is a newer, smaller, and RSpec compatible framework. And it's actually quite elegant when you compare the code underneath the scenes. Chris, too, I'm not going to bother trying to pronounce his last name, wrote Bacon and TestSpec, which are new minimalist specking alternatives. And I wrote something called MiniUnit, which I've extended recently to include tests, specs, and mocks, and it's less than 1,000 lines of code. So let's just kind of compare. Here we have test unit, mspec, and rspec. And these guys are, I'm graphing the library size and the test/spec size. And these numbers are kind of bullshit. They count the comments and everything, but it gives you an idea of the magnitude of these libraries. And what I really want to just point out is that the y-axis goes up to 15,000. And these numbers aren't added together. They're just side by side. Here's Bacon, MiniUnit, and TestSpec. And then MiniUnit includes the other stuff. I need a new name for MiniUnit, but we're not going to ignore that. We're going to ignore that for now. And this is to the 15,000 scale. And you really need to just go back and forth to really compare what they're doing. Now, they're not compatible with the previous systems. Well, actually, MiniUnit's test side is, but I'm not compatible with RSpec's API, and Bacon doesn't try to be. But it's severe, and if we go and look at it with a natural scale on the y-axis, you can see that these things are small and simple and clean. I think Ruby sadism and asceticism are really, really powerful. Getting there is not easy, and it requires understanding yourself as much as you understand the code, and that's why I've been working on something that I call introspection-oriented development. What it involves is asking yourself a bunch of questions. How do I do better? How did I overlook that bug? Where am I lacking clarity? How can I use my tools better? Where do I waste most of my time? How do I focus better? Where am I holding myself back? Am I wrong? Can anyone else think of any other questions you might ask yourself? Turkey?
What was I thinking?
What was I thinking? Exactly. You go back to your code 2 weeks later, once it's legacy, and you're like, was I high? That's one line if I just delete it all and rewrite it like this. Yeah, exactly. So if you ask yourself these questions constantly, you're going to improve over time. And other forms of improvement come from reading. Check this out. 1 nerd book a month is 12 times the industry average. That's pathetic. Come on, think about that. 1 book a year is the average. So if you're reading 1 book a month, which I don't think is that big of a deal, you are soaring over the industry. Read c2.com, one of the best, the original and one of the best wikis out there, and other wikis with smart people. Get as close to the experts as possible. I think the wikis are important because they're constantly refined, and the experts go to them, and there's a lot of really good signal and noise there. Read 10 to 20-ish smart blogs. Limit yourself. Focus on the ones that you're willing to pay attention to and really learn and grok what they're saying. Ignorance is not bliss, though. Erica Good at New York Times reported on Dr. David Dunning's work at Cornell, where he studied people by giving them tests in stuff that they knew and didn't know. And before they graded the test, they asked the students, or the people taking the tests, how well they did. And it turns out that the people that don't know what they're doing thought they were great. And the people that did know what they're doing thought that they sucked. People who do things badly are usually supremely confident in their abilities, more confident, in fact, than people who do things well. So ignorance is not bliss. The more you teach yourself, the more you know what you don't know, the better you're going to be. Focus. Stay away from what the fuck, coding horror, and other idiot forums. They rot your brain. And really, what are you going to learn from people who think VB is a viable language? Trim the bazillion blogs from your newsreader. It doesn't help. It's the noise on the signal and noise ratio. Get rid of the high flow mailing lists. They are nothing but noise. And work on what's actually important. Stephen Covey in 7 Habits of Highly Effective People came up with this really interesting graph where they work a quadrant into activities. And it's got 2 axes, important, not important, and urgent and not urgent. And it should be said that it's not bad to do the not important, not urgent things like go to YouTube or watch TV and wind down. Those are actually really important for fighting burnout. Just don't spend a majority of your time there. Likewise, don't spend a majority of time on the not important, urgent stuff. The firefighting, the meetings, most of your meetings are not important and they're not urgent, but they pretend to be. So push towards important as much as you can, as needed, and proactively work from urgent to not urgent. Work on prevention, work on proactive planning, work on implementing systems and burnout prevention, and you're going to have a lot more effectiveness over time. That same manager used this phrase with me over and over, because as you can guess, I'm a tad feisty. Do you want to be right, or do you want to be effective? I eventually learned I want to be effective. Grow yourself. Learn 1 new language a year. Learn your tools in depth. Now learn them in depther. I've been using Emacs for 15 years, and I'm not done learning, and I'm not done refining that system. Examine your development habits. Code with other people. It's a really good way to compare and contrast how you think and how you work in your development process. Study something non-coding oriented. I've worked with physics coders, biology coders, musician coders, and they all bring fresh perspective to the table. They're interesting people to work with. And push yourself. Write more code, lots of it. Junk code is great. Write stuff to throw away. Write stuff because you just want to figure something out. It doesn't matter. Quantity can't be greater than quality. Pottery teacher once told half of his class their grade is going to depend on a single piece done at the end of the term. He told the other half their grade is going to be based on the volume or the weight of all the pieces they do throughout the term. Well, which half do you think produced better work in the end? Not a trick question. One half sat around twiddling their thumbs, theorizing about the ideal pot. Now, that's valuable in some regard, but not in others. The other half learned about the ideal pot by making lots of bad ones and learning from their mistakes. Practice makes perfect. In Art and Fear by Bales and Orland, they said, the function of the overwhelming majority of your artwork is simply to teach you how to make the small fraction of your artwork that soars. One of the basic and difficult lessons every artist must learn is that even the failed pieces are essential. That's just as true for us as it is for artists. By extension, the more you reduce the cost of failure, how many pots you can do, how fast, the more you accelerate your feedback loop, and that can be used for self-improvement or accelerating development or whatever. Tighten that feedback loop and you're going to get more out of it. More data points, more experience, more everything. Unit tests are a really good example of reducing the cost of failure. We've taken verification away from this over-the-wall mentality of QA and said, well, developers are going to write their own tests so they can get feedback quicker. It's no longer a 2-week thing. It's no longer a 2-day thing. It's a 2-second thing. And if it's 2 seconds, your tests are too slow. Push yourself more. Be competitive. Competition is practice. Challenge the status quo. They're almost always wrong, even when they're right. Don't be a sheep. And feel. I think this is really, really important. Let your emotions flow. Have an opinion. But remember, there's a fine line between someone with an opinion and an asshole, so don't let them rule you. Zentest, Flog, and Heckle all came from my love of good developer tools. It's why I coded in Ruby. Ruby was really rough around the edges when I started, and I knew that there was a lot we could do for that to improve the development process. Vlad and image science came from my hate of impossibly complex code. I spent 10 hours debugging one Capistrano bug before I wrote Vlad. I didn't do it in a vacuum. I didn't do it just so I could compete with Capistrano. God, I don't want to work on deployment scripts, but I needed to remove this complexity from my process and from my life. It was getting in the way. And very, very important, use feedback. Ask for it from your code, from yourself, from your coworkers, from everyone. Listen to what it says and feed that feedback back. That's one of the most important things you need to do is constantly refine. That's what it's about. Find your balance. Between 0% action and 100% action, and 0% thought and 100% thought is your sweet spot. Dig for it, find it, grab on, and don't let go. Once you find that, you're going to be a truly effective developer. There are tools that can help. Autotest is obviously one of them. You probably didn't realize that using Autotest was a form of sadism and asceticism, though. It's sadistic in that you're constantly pounding on the code. It's ascetic in that you're being highly disciplined about your testing practices. Every time you save, you verify. Boom, boom, boom. And that pace is what I'm talking about on tightening the development loop. That's why we wrote Autotest. It gives you more information and it gives it quicker. Flog is another tool. It's a complexity reporter based on ABC metrics. ABC stands for assignments, branches, and conditions. It's a simple white space independent way of measuring the complexity of code. The numbers themselves seem to be contested a lot, but what people don't seem to understand is that the numbers themselves are useless. They don't matter. What's important is the numbers relative to each other. The higher the flog score, the harder it is to get complete and good test coverage. Here's an example. This if statement is 132 characters long, and I can't look at it and immediately tell you what it does. And I think that all code should be able to immediately tell you what it does just by looking at it. Even after studying it, I couldn't tell you what it does. So we dig in, and I still think that the cursor thing, there we go. So if model keys inject true, B class, BN class, constantized columns, map, ampersand name, include, association options, foreign key, then. Everyone got it? Good. I didn't either. But what I can tell you is that there's an inject, which if anyone reads the mailing list knows that I hate. And there's a bunch of stuff inside the inject block. So that's important to note that there's a bunch of things in here that are constants. This does not change throughout the inject. So let's pull it out, refactor it. So we make an FK variable, pull that data out, and stick that in. And it's a little bit smaller. We're changing our averages. We're adding lines, but we're shortening them. And so then we look at it again, and we say, well, we've got this model's keys that we're going over, and for every single key in there, we're getting constantized columns, blah, blah, blah. So let's pull that out, because that's actually a constant across the inject. So we say columns equals blah, blah, blah. And now we say if columns inject, B and column include FK. At this stage, I can start to intuit what it is. What it really is if all columns include FK, do something. Now this is a lot more clear to my brain than the other one ever was. I think that one of the greatest things about Ruby is that you can read it over the phone to someone, and they're going to understand more or less what you're saying. Ruby's very, very readable. So let's do one last thing. And let's take the ToProc, which, as many of you know, I hate. Let's take that out, because we don't need clever code in there anymore. And one of the things I should say is that we've made it understandable first before we've started correcting other things. So we take that out, and we make it a regular map that's calling c.name, and you get a huge speed benefit out of that, because ToProc's really expensive. And I should say that that's just a value added. That's all it is, because it's about understanding it. Now that you can read the code and tell what it's doing, you can come back 2 weeks later once it's legacy, and you can understand it again. So it's cleaner, clearer, and much, much faster. Another is coverage tools. They are awesome at showing gaping holes in your tests. Very, very good. Excuse me. But they do not signify quality of tests at all. This is a nonsensical statement. We have 100% coverage, should be questioned every time someone says it. So what I say? You can have 100% coverage with 0 assertions in your tests. Why you would have tests with 0 assertions, I don't know, but you can. You can have 100% coverage without ever verifying anything. But more often you have bad assertions. But the absurd example here is that the meaning of life, returning 42, isn't actually verified to be 6 times 9. So what does coverage mean then? Nothing. Coverage is an X-ray of the code world. It is a really, really awesome tool, but you don't use it when you're bleeding out. Use it when you have a broken bone. I wrote Heckle. It's the most sadistic tool that I've ever written. It has a new logo. And what it does is it runs your tests, and if they all pass, and then on the fly, in memory, modifies one of your pieces of code, whether it's a condition or a loop or what, an argument, a value. It modifies it, and then it reruns your tests. And if your tests don't fail, you didn't test something. And it does that for every single combination of mutation that it can figure out. It's brutal. I've got one package that is fully Heckle proof, and it's my least used package. It was PNG. And I did it to see if Heckle was viable, and it is. It's a lot of work to make sure that you've got good coverage of your code, but it's important. That's what we're doing here. So we're writing quality stuff, and we need to make sure that it's right. So this is something I don't normally do. I don't normally repeat myself in talks. I think this is important, though. Enjoy hurting bad code, and you're going to have less of it over time. Practice severe self-discipline and abstention. Eschew complexity. Practice introspection-oriented development. In other words, know thyself, improve thyself. Use every tool you can, but use the right tool for the job. And have an opinion and feel for your code. That's why we do this. We do it because it's fun. We do it because we love the code. In closing, Frank Herbert was wrong. Fear is not the mind killer. Apathy is. It numbs you. You have to care about the code. Love it or hate it. Either is preferable to apathy. Preferable to the developer says, I'm just paid to write code. Who worked with that person? I did. A lot of you did. Because you're going to wind up maintaining their code because they will move on. You're going to hate their code. You're going to hate their impact on the project. You're going to hate their impact on team productivity and morale. So love the code or hate it. If you love it, nurture it, grow it, make it beautiful. If you hate the code, hurt it, pare it back, rewrite it. Just be passionate about what you work on. Otherwise, you're dead inside, and so is your code. Thank you. Any questions? Blue shirt. You're sitting in my seat. Water. Dying.
Okay. So I was just interested in hearing about how you integrate Heckle into your day-to-day development. Is that something you set aside time for, when you're completing a check-in, or when do you run it?
I run it when I'm feeling masochistic. Like I said, it's really brutal. It's really brutal both to your code and to you. So once in a while, I have in ZenTest, there's an Autotest plugin now that allows you to just plug in Heckle. And you can say require Autotest/Heckle and then give it a module or a class name that you want to focus on at that time. So when I'm feeling either masochistic, I want to hurt myself or hurt the code, which I unfortunately get into sometimes, or if I'm feeling confident about my tests and I want to poke holes in it. If I think, wow, this is really solid, well, let's prove that. Because archive says I've got 100%, whoop-de-doo. But Heckle says I'm missing a lot of stuff. I'm not dealing with these edge cases. And it's really good at finding edge cases. Anyone else? Way in the back? Sorry, before I answer your question, did we record?
Yeah.
Awesome.
That's great.
Thank you.
So what does Heckle do to show you where it found a problem?
So it runs for a really long time, because while Ruby to Ruby and parse-tree, which is what it's using under the covers to do this stuff, are actually pretty fast, there's just so many combinations, because every time you have a branch, every time you have an assignment, every time you have pretty much anything anywhere, there's something to modify. So a simple method can have 30 different things it wants to do. So it makes one modification, it evals it, it reruns those tests, and so that time adds up quite a bit. So like I said, it looks for things that it can modify, it modifies it, it reruns the test. So you see that there's a failure, and then it sees that there's a failure, and it shows you the before and after of the code. So you'll see a method in its original form, and you'll see a method in its modified form. And I didn't bother running it through diff or anything, because I wanted you just to look at the whole thing. That could probably be pretty painful with larger methods. But you shouldn't have larger methods anyway, so whatever. So you see this side by side, and you can go, oh, well, it changed that if to an unless, and things didn't break. So I'm missing something that tests any of the code inside that condition. Yeah, there, in the back.
With all the talk about introspection that you were doing, watching yourself, in the different kind of ways that you spent time in your coding and stuff, did you notice things changing over time, the way that you worked? And if so, how? Constantly.
The only constant in life is change. I see myself learning from my mistakes. I see myself coming up with new ideas and integrating them into my process or my way of thinking. It's life. It's constant. But the point is to be aware of it rather than just let it continuously go by. We're all learning and evolving as time goes on, but if you're more conscious of it, you accelerate that process. Anyone else? That's it? Turkey. Thank you.